Welcome to ePathshala lecture series in computer science. This is a course in cloud computing. Today we are going to talk about virtualization that is used in cloud. The learning objectives of today's class will be like this. We will first look at an example which is equivalent to a library and a server room equivalence, and from that we will understand what is virtualization, and we will see the problems or the difficulties of normal environment of a computer system, and hence the need for virtualization from that layered architecture, and we will see the goals of virtualization, what we want to achieve, followed by the summary. So, as we have mentioned in an earlier module, let us do a quick recapitulation that for any new technology, we need to know the foundation technologies, which for cloud it is distributed systems and parallel computing. We need to understand or learn about the enabling technologies. For cloud, the enabling technologies are virtualization and service oriented architecture, and we need a dependent set of technologies. For cloud, it is the P2P or peer to peer architecture. So, we have looked at in earlier modules the distributed systems in details, because that is the fundamental technology from which cloud has evolved. We have also looked at briefly what is parallel computing and how it is useful in cloud. Now, today and in the next few modules, we will look at one of the enabling technologies, which is virtualization. So, first let us look at an example. It's in a library, it contains many books. Library has many books on different subjects, which is being borrowed by the members. So, here is our library room, where we have many books arranged in shelves. Now, these books will be divided into subdivisions. These are the various kinds of subdivisions, maybe fiction, maybe drama, maybe history, maybe engineering, maybe literature. Various subdivisions of the books will be there, and in this library, to handle the borrowing and lending, etc., we have each subdivision being manned by an assistant librarian. So, these are our assistant librarians near the shelves. So, each subdivision has one assistant librarian who takes care of the books. The library will have members who will come to borrow and return books. So, these are our members. They will regularly come and they will borrow books and they will return the books. Now, a member needs to know who the assistant librarian is for the sake of borrowing a book. So, if I have a specific choice as a member, I should know which assistant librarian I should go to in our scenario of library, and I should talk to that particular assistant librarian. So, according to based on the choice of the members, member will go to specific assistant librarian and will interact with them for a book. Now, what is the problem with this scenario? This scenario should work fine if nothing changes, but in a changing environment, this scenario does not work. Let us see why. The first problem is we need to know, as a member needs to know the specific assistant librarian handling the specific subdivision. So, new member needs to be acquainted with that setup. Second of all, if the requirement of one subdivision reduces, then can I merge two subdivisions and say that okay, now the need for fiction is reduced, so I will merge it with literature or merge it with something else. So, and put one assistant librarian. Again, the member who is or members who are accustomed to the fiction assistant librarian handling fiction will not be able to get that service. If one sublibrarian does not come, then can we ask another sublibrarian who knows this subject of books also to handle it? same problem will happen, that the members will not be aware of this. Now, if a library wants to replace one sub-librarian, assistant librarian with another librarian, it will greatly inconvenience the members. So, we see that in this system, if nothing changes, then a new member coming in is the only problem. The new member gets to know the specific choice and the specific sub-librarian, assistant librarian, then it works fine. But any change, this system cannot tolerate any change. So, we draw a simile to our server room. In a server room, we have a similar situation. Let us look at a traditional server room. So, we have a machine, each machine running specific application. So, we have one machine which contains the hardware, the operating system and the application, and this particular machine is dedicated to web servers and it has the Windows operating system. We want to run another application which is the app server. Then we have another machine, physical machine we take, and we run the Linux operating system and the app server. A third machine will run the database server and it will be perhaps on Linux operating system. A fourth machine will run the email server and it will be running on Windows. So, in a traditional server room, each application, or maybe combining one or two or three or four applications, will run in a specific machine, and that machine will have one particular operating system to run the application. So, what happens in this traditional system? If one server is down, machines will always go down. So, if one server goes down, say the machine number 4 goes down, then what will happen? The email will not be available. Till this machine does not come back up, we cannot access the email. So, let us go back to the library and see what is the solution for this. How do we solve this problem? So, we look at the library, and what we want to do in our traditional library, rather than the members interacting with the assistant librarians, we will create one layer of indirection. We will create a front desk, and this front desk will have one librarian who will be handling all the requests. So, what happens to the sub-librarians? They will be behind the front desk. So, they will not interact with the members anymore. Only this librarian interacts with the members. So, when members arrive, they interact only with the specific librarian at the front desk, and this will have the advantage that whether I have the number of assistant librarians or sub-librarians that we have, whether that reduces greatly to very less number, whether I have different sub-librarians or assistant librarians for different shelves of books, none of these will matter to the members. The members only know the librarian and the front desk librarian, and this front desk librarian will be able to manage the whole show with the help of the sub-librarians. So, how is this equivalent to our server system? So, our server room, we have 4 machines running 4 different applications on 2 different operating systems. 2 applications are running on Windows and 2 applications are running on Linux. Now, what we want to do is we want to have one machine. If we look at this diagram, this is one hardware. We put a front desk like indirection layer, one layer of indirection, and on top of that we have put the 4 applications. Now, we have to understand that these 4 applications are running on 2 different operating systems, but this layer of indirection will take care of these 4 machines running on top of the same hardware. The hardware is visible inside these application smaller machines are actually not the physical hardware, they are the virtual hardware made accessible to the applications. This particular layer is called the virtualization layer, and with the help of this virtualization layer we can ensure that our server room gets modified. So, now we have one machine. So, this hardware that we see below belongs to one particular machine. We have 4 applications. We have 2 different operating systems running in this. So, what is virtualization? This method of putting indirection layer in the environment is called virtualization. So, when we can put this kind of indirection in our computing environment such that one or many operating systems can run, we use the hardware and the software in a simulated environment or even an emulated environment. In a time sharing basis, we allow the particular machine being shared by more than one applications, then we call it a virtualization. Let us look at a formal definition. A formal definition says it is a framework or methodology of dividing resources of a computer hardware into multiple execution environment by applying one or more concepts such as software partitioning, time sharing, partial or complete machine simulation, emulation, etc. So, let us go back to our diagram. We have, this is one machine where we have one operating system, we have the hardware, OS runs on top of the hardware, and we have the applications running. Multiple applications can run on top of the operating system. We can have many applications running on top of the operating system, but there is only one operating system. Now, if I want to run my email server, app server, web server and all other servers on this particular system, what I need is I need 2 different operating systems. So, we saw 2 of the applications are running in Windows operating system and other 2 are running on Linux operating system. So, therefore, the same hardware, if we are able to put 2 operating systems, then we can have the environment like our library in our server room. But it is not possible. Why is it not possible? It is not possible for specific reasons. Let us look at the multiple OS problem. Running simultaneous multiple OS, what is the problem? The computers typically have layered architecture. What is the layer? What are the layers? The lowermost layer is the hardware, and operating system runs on top of the hardware. So, OS caters to a specific hardware in the system. So, this is the operating system, hardware and the applications. But the OSs need some assistance. They are not run in the on the bare metal. So, what helps the OS to run on the hardware is known as the instruction set architecture or ISA. Every hardware comes with a specific ISA, and that ISA has the set of instructions. This is an abstraction of the hardware abilities, and operating system is written to interact with the specific ISA. This ISA is the abstraction for the hardware. So, what happens is that the ISA is tied to the hardware. So, for a specific hardware there is a specific ISA, and operating system is a software which will be written for a specific ISA. Therefore, we have a combination of operating system, ISA and hardware. They are all tied together. A specific operating system can be written for a specific ISA. A specific ISA can be abstract a specific hardware. So, this ISA layer is tied to the hardware, operating system is tied to the ISA, and applications are tied to the operating system. This way, we have everything tied to the next layer, and all are a part of the group. So, applications to the OS and specific hardware. So, all these will be combined to form one group which cannot be broken. So, if I have another operating system, that operating system may be able to run on top of the hardware, but the operating system will be written for a specific ISA, and two operating systems running simultaneously on the hardware will not be allowed. Let us look at this mechanism. But when we say two operating systems cannot be run, we think of a dual boot system. What happens in a dual boot system? A dual boot system is a machine which can run two operating systems. Let us see what happens in a dual boot system. This is an example of a dual boot system where we have the operating system 1, operating system 2, one specific set of hardware. The hardware has processor, memory, etc. However, the storage is not shared between the two operating systems. What does that mean? This means that operating system 1 will separately use storage 1, whereas the operating system 2 will exclusively use only storage 2 and not together. Together they will treat the ISA and the hardware similarly. So, what happens in this kind of case is that one operating system will use the ISA, say some registers, the stack, all the hardware specific infrastructure, one operating system will use in a certain way. Simultaneously, another operating system cannot use the same hardware. We cannot allow, because one operating system may be storing certain information in one register, the other operating system will not be able to respect that. So, therefore, two operating systems running on the same hardware is not possible. But this, the solution to this is the virtualization. We create a layer of indirection on top of the hardware and put the two operating systems on top of the layer of virtualization, and these two operating systems, if they are both written for the same ISA which is lying under the virtualization layer, then it should work. So, this is the concept of virtualization. Diagrammatically, if we see, now we can contrast the dual boot with the virtualization. Here we have, these are called virtual machine. This is one operating system and this is another operating system. Then the hypervisor or the virtualization layer is running, and underneath we have the storage hardware, all the hardware resources under this, and this way it is possible for us to have two operating systems running on top of the virtual machine, on top of the virtualization layer. So, let us go back to our server room. Now, instead of these 4 different machines, what we can do is, now we are not worried about having 2 different operating systems, because with the virtualization layer we are able to overcome the problem and run 2 different operating systems simultaneously, not like dual boot, but simultaneously on top of my hardware. So, therefore, now I can have one machine, say first machine 1, I have the hardware, I have the virtualization layer, and then I run 3 of these applications along with their corresponding required operating system and along with their virtual hardware. This set is called a virtual machine, and I am running 3 virtual machines which are running 2 different operating systems, Linux and Windows. Similarly, in machine 2, I am running 2, one is Windows and another is Linux. In machine 3, I am running 3, 2 Windows and 1 Linux, and in machine 4, I am running again 2. So, each machine now is capable of running all 4. Any machine will be able to take all 4 because it is capable of running 2 different operating systems simultaneously. So, whether I need the mail server or I need the web server or I need the app server, it is fine if I run it only in one machine, or I can run, as we have seen in this example, we can run them shared in all the 4 machines. So, now if say a virtual machine crashes, we have no issues because we are running the same virtual machine of a certain application in other machines also. So, we can easily make good of that. Now, if one full machine crashes along with all its virtual machines, there is no problem because the same virtual machines are running in other physical machines, and therefore, there is no problem. Or even if these virtual machines are required, we can migrate these virtual machines to other physical machine and run the same virtual machine. So, let us look at the actual goals of virtualization. When we create a virtualization layer, what are the objectives or goals that we have in mind? We want to allow a network enabled device to access any application over the network, even if that application is actually not meant for a certain type of device. So, even for a different ISA, we have been given example of the same ISA, even different ISAs can be used for running the application. Isolation. So, each virtual machine, as we saw in the example, virtual machine of email server is isolated from the virtual machine of the app server. So, therefore, they are more secured and they are more manageable, they are not on the same platform. Isolation of the application from the OS, allowing an application to continue to function even though it is designed for a different version of the operating system or a different operating system altogether. We can run that. Continuing with our goals of virtualization, it gives us the ability to increase the number of users working on an application, since multiple instances are now running on the on different machines simultaneously. So, earlier on we saw that one server is running email. Now, if the demand increases for email at a certain point in time, because many people want to interact, we simply run more email virtual machines on more machines, and therefore, a number of users that can use the specific application increases. We also have the ability to decrease the time it takes for an application to run by segmenting either the data or the application itself and spreading it across many systems. The ability to run the same application on different systems is very useful, and that gives us the strength and the power of virtualization. Further goal is optimizing the use of a single system, allowing it to work harder and more intelligently. Let us look at an example. So, here is an example where I have one server or a couple of servers having some application and data. This is the usage, the blue is the amount of CPU time that is being used. This is another app server, this is another server where application and data are running, this is the usage, and a third set of servers, this is the usage. Instead of running all these in different machines, if we look at the amount of usage, any one machine will be capable of running the whole data. So, that is what we have done in this. In a virtualized environment or a virtualized world, we can bring in all the applications and data together, and we can put it on the virtualization layer, and now depending on the need, we can use any one of the machines, the other machines being free, therefore, they can be shut down. In this time of trying to use less power as possible, this gives us a very huge advantage of using virtualization. Virtualization also increases the ability and the reliability and the availability of an application or workload through redundancy. Number of VMs can be run. So, we can have a redundant amount of applications running. If any component fails, there will always be another component which can be equivalently used. So, after so many days of computing with so much of concern, the question that arises today is, why now? What happened now to have the to have this virtualized environment, and why we are talking about virtualization so much? We see that machines, average machine has become of higher capabilities. So, machine has more capability, but we can't depend on one machine because of the failure. So, we buy many more machines, and each of these are having a lot of capacity. Therefore, that capacity is wasted. Therefore, underutilized hardware and software resources. We have so much of hardware and software, but we cannot use them. Lack of space. We want to buy more machines, but we do not have space for them. So, therefore, buying more machines makes less sense, and we can have less number of machines. If we can manage with lesser number of machines, then it is much simpler. Green initiative that we were talking about a little while back, that the less amount of power we can use, the better it is for all of us, all around us. So, therefore, virtualization definitely helps us in our greening activity. And administrative cost. The larger is my data center in an organization, the bigger will be the administrative cost, the running cost, the even after buying the hardware, maintaining them, ensuring that they are all working fine, maintaining the software versions, all these are very huge issues that users face, and therefore, we need to cut down those costs. So, all these reasons have today, with all other technologies developing, has given rise to the increasing need to use virtualization, and that is what is happening in a cloud environment. So, cloud is a fully virtualized environment, and we will see how this virtualization helps cloud in our environment. So, to summarize this module, we looked at what is virtualization. To understand what is virtualization, we looked at a library example where we saw, like our different servers, the different bookshelves are allocated for different specific category of books. Just like we saw the simile, and we said that each application is run on a separate server. And then we saw in our library example that these books will have to be handled by a librarian, and we assign one assistant librarian per such category. And then we saw that the server room has one application, each server has an application running on a specific operating system. In our library example, we saw that if we run this setup, then the members will have a lot of problems if they are coming for any different kind of book, or there is a change in the assistant librarian, or there is a lack of assistant librarians on a certain day, etc. Similarly, in our server room, if there is a machine that crashes, or something is not working, or some component is not working, it is very difficult to manage. Next, we looked at the goals of virtualization, where we saw that the basic goal is that I need to use my server hardware more intelligently than if I do not do anything. So, normally what we will do is we will buy a lot of hardware, and we will buy all versions of our software, and we will install and use them. But in a virtualized environment, with lesser number of servers, we can get a better service. So, to give that benefit to our users, a cloud environment will be completely virtualized, and that is what we saw in our goals of virtualization. And finally, we saw that why today with the advancement of the technologies, with what has happened to our computing world, virtualization is the most suitable technology that needs to be that is to be used. We will continue with our virtualization and different aspects of virtualization in the later modules. These are our references. Thank you.